fractions together, they have to have the same denominator, right? So what would I need over here? A 4. So I'm going to take this fraction and multiply the top and bottom by 4. And then over here I need a what? X squared. So I multiply top and bottom by x squared. All right, let me rewrite what we have and then we'll proceed. Is that me? Oh, okay. No, it's all right. Can't tell with my ringer these days. So many different sounds for different things. All right, where are we? We have 4 over 4x squared minus x squared over 4x squared, and then over x minus 2. Notice I wrote the limit again, right? I expect on your work for you to be writing the limit every single line. You know, each line equals the next line. It shouldn't just be like your random thoughts scribbled on a page. It should be logical, like step by step what's happening. Questions? You're finding a common denominator. You're combining two fractions together, right? We're taking these two fractions, trying to put them together with the subtraction, so they have to have the same denominator. Let's see. So I have the same denominator. Now I can combine them. So it's 4. We combine the numerators, 4 minus x squared over the common denominator, 4x squared, but then all of that over x minus 2. Right? That's what happens when I put those two together. I get this. Questions to that point? So I told you the first, like the rule of thumb for complex fractions is to try and put those two fractions together. Done. We've done it. Now what? Now it's, do you see anything? Did that help? Did that get any better? Or what? I mean, does anyone see something?
Take out the 4 from 4 squared on the denominator.
Could you take the 4 out and put it where?
Make it like 4 minus x squared.
You could separate those two. You could. I mean, it's not, I don't know if that helps us though. Like you could separate those two, but it's multiplication, so you don't necessarily need.
I was thinking maybe you could cancel out the negative x squared, but not.
Oh yeah, no, you can't do that because you have a 4 up there. You could split it into two fractions. Keep looking, it's there.
Are we going to put x minus 2 over 1 and flip them and multiply?
Okay, so you want to say, so you see a fraction here, you're saying, can we take the x minus 2 and look at that as being over 1 and then flip it like that? Is that what you're...
like separate them and
then flip? Yeah, you can do that. That's completely legal. And actually, we will do that. We will do that. I'm going to leave it not there yet, okay? We will do that. That is a step that's about to come. I want to see if anyone sees why we're going to do that in a minute.
oh, you can factor out.
Yes? Can't cancel anything yet.
Would the numerator from the top be different squares?
Yes, there you go. That's a difference of squares. 4 minus x squared is a difference of squares. Isn't it? Okay, so let's factor it. Okay, it's going to be, what is that? 4 minus x squared factors to be 2 plus x, 2 minus x. And then the bottom, 4x squared, and then all of that was still over x minus 2. Everyone see the difference of squares up there? How are you supposed to actually know that 4 minus x squared is a difference of squares? How are you supposed to know that? Well, because you took college algebra, and difference of squares was covered in college algebra. And so there's an expectation here that you see that. And I understand for some students it's not going to become natural, or this is not natural right away, but it's going to have to become something you're looking for, that you're paying attention to, right? Because if you don't see those things, it's just, this is where it ends in terms of, this factoring is is here. It is present here. Okay, I factored. But did that help us? I mean, did we gain anything from this? So there was a suggestion here that maybe what we could do is we could look at this x minus 2 on the bottom as a fraction, like that. So let me show you where I'm going before I actually do it. Do you all see that x minus 2, this right here, is almost that factor right there? What's the difference between x minus 2 and 2 minus x? What's the difference? They're off by sign. We had that earlier, didn't we? Where they were off by sign, and what did we do? We pulled a negative out, didn't we? And we got them to cancel. I'm going to do that. Again, I'm seeing that right now, that this and this are going to cancel after I pull a negative 1 out. But I need to convince myself that these two will cancel. So what I'm going to do is write this as a fraction, and then I'm going to flip. Remember, division is the same as multiplication of the reciprocal. So taking that and dividing by that fraction is the same as multiplying by the reciprocal, which I'm going to write on the next line. So I'm taking 2 plus x, 2 minus x over 4x squared, and I'm multiplying it by the reciprocal of the bottom, which is that. So all I'm doing is taking that, flipping it up like this. And does that help convince you that these two are lined up to be able to cancel like this? Does that help you see that these will actually go away at some point? Next line. Okay, I'm going to factor negative 1 out of that factor. So when I pull a negative 1 out of both of these, it creates a negative x and it creates a positive 2. And there's a negative 1 out in front now. And if you're unsure what I'm doing, just distribute that negative 1 back through and you get this back, right? And the reason I did that is because this technically is really 2 minus x now, isn't it? I mean, negative x plus 2 is the same as 2 take away x. And that means I can cancel this factor with that factor. As long as I promise you, little asterisk, as long as I promise you that x can't be 2, right? Limit. Still have a limit. I have not let x go to 2 yet. What is still left on top? 2 plus x, the only thing left, right? Okay, on the bottom, what do I have? 4x squared and a negative 1. And be careful because this is multiplied. So it's not 4x squared minus 1, it's 4x squared times negative 1. So it's going to be 4x squared times negative 1. If you want, you could have just put the negative in front of the 4x squared, but there we go. Now, let x go to 2. So no more limit, and I shouldn't have any more problems either, because I canceled the part that was causing the problem, right? I got rid of it. So if I let x go to 2, the top is 2 plus 2 is 4, and then the bottom, 4 times, let's see, 2 squared is 4 times negative 1. So I believe you get negative 1/4. Right, you get 1 over negative 4, which is the same as negative 1/4. Remember, for fractions, whenever you have fractions, it doesn't matter where you put the negative sign. Right? Your negative sign can be on the bottom or on the top or out front. If you can float that thing around. Okay, so first problem, difference of cubes. Second problem was a conjugate. Third problem was combine, get your common denominator. Then when we did that, we saw a difference of squares. Then we had to pull that -1 out again. I like to give problems where that -1 has to come out. It's an additional skill that you need, that shows me you see something more than just if it were exactly the same right away, they cancel. That additional -1 is something I like to make sure you know how to do. Okay. All right, we've got something new here. What's new? What's new? I have a root in the denominator. Yeah, something else that's a little more subtle, I guess. Different variable. I'm using t instead of x. Big deal, right? It's a dummy variable. It's still a limit. I'm trying to let the letter t go to 4, and here's the expression. What happens when t goes to 4, or when I try and replace t with 4? All right, let's do it. Always check first. Always check first to see what you get. So let's plug in 4 on top. See, 4 times 4 is 16, minus 4 squared is 16. I get 0 on top. On the bottom, 2, take away the square root of 4, but the square root of 4 is 2. So this is going to give me 0 over 0, right? This is bad. Got to do some algebra or trick. Always check that first. Always check that first. I'm going to scroll up for a second. I want to go back to the very first problem that we did here. Remember that first problem where we plugged in 1 and there were no issues and we just got an answer? Right? You didn't have to do anything? Always, always check first what happens, because if there's no problems, you're done. What will happen is students will get so bogged down in this algebra that they'll get to a problem and they'll stop checking. They'll just assume it's 0 over 0, and then they're wasting their time, right? Because the problem could have been finished in a couple of seconds. So check always first. All right, where are we? All right. There's a couple of ways to do this problem. So, and I should mention that as well. There's not a universal, every problem has to be solved the same way. There are multiple paths that get you to the answers on these, just depending on the algebra you use. All right, any ideas? Yeah, you could multiply the conjugate. You could look at the bottom and use its conjugate, but you have to do it on top and bottom. Yeah, you could do that. You want to do that?
Yes, please.
Okay, let's do it. Is that legal? Is that a legal move? Is it going to get us to the answer? I don't know. We'll see. It's gonna work, but you're trying something, right? That's the whole point. You have to try something, and it looked like the conjugate worked before when we had a square root, didn't it? But now it's on the bottom, so let's try it that way. So let's do, what, 2 plus root t? 2 plus root t here, like that? Is that what you want me to do? Yeah, sounds fair. So I'm multiplying by 1, which never changes the problem, right? You can always multiply by 1, and that has no impact on the problem. I'm going to rewrite limit t goes to 4. All right, when we multiply, let's do this. Remember, the numerator, you have to multiply those two together like that. And on the bottom, you have to multiply these two together like that. Now, this is where things can get a little bit messy. If you look back in the notes, when we did the other conjugate one, right? When we did the other conjugate one, we multiplied out the top, didn't we? But we left the bottom alone, didn't we? So that something would cancel. Here, because we're doing the conjugate of the bottom, we're not going to multiply out the top. we're just going to multiply out the bottom. So it's kind of like the opposite. We're going to FOIL these two together, but we're going to leave the top just like that and hope that something cancels. Let's see. Just leave the top alone. And on the bottom, okay, do your FOIL. Hey, those are conjugates, right? And when you multiply two conjugates together, the middle terms always cancel, don't they? So all I really have to do are two multiplications. The first one's together, which would give me 4. See, I don't have to do the next one, right? This one, like from here to here, that one and that one are going to cancel each other out. So the only other thing I have to do is these two together. Be careful there. What do you get if you take negative root t and multiply by positive root t? Negative square root of t times positive square root of t. These two come together to become negative t, right? This will become negative t. So minus t is down here. Questions on that? All right. Yes?
So we're leaving the top alone because we're taking the conjugate of the bottom?
Yes.
Okay.
Because we did the conjugate of the bottom, we're hoping that the bottom gets nicer and that it will cancel with something on top. If we try and multiply out the top, it's going to be a mess. Because we're really hoping something cancels here. Does anyone see it? Something cancels, but not quite yet. What is it?
If you yank the t out of the top left, out of that one,
Right here.
4 minus t.
You've got to see that you have to pull a t out of this. Do you see how both these terms have a t? Pull the t out, and what would you be left with? Pull one t from here, what would you be left with? 4 minus t. That's exactly what you have down here. You see? So I'm going to go limit, t goes to 4, pull a t out of that first factor, that first factor, 4 minus t, and then 2 plus root t, and then all of that over, 4 minus t. Now in the denominator, I don't need to put this in parentheses. That doesn't have to be in parentheses, but I'm trying to just show you again, like these factors are going to go away. So can I cancel them out now? Yeah. As long as I promise you that t will never be 4. Right? I can do this as long as t is never 4, but that's okay because I'm approaching 4. I'm not actually going to be 4. We're almost there. Limit t goes to 4. All right, up top, I still have a t. I have a 2 plus root t. On the bottom, I have, oh wait, what's on the bottom? 1? Okay, so I don't even need that, do I? I don't need to put over 1. I could, but I can just leave it like that. I'll put it over 1, okay, because it's not going to matter. I still need to plug in 4 now. Questions? Replace t with 4. 4, so I no longer write the limit. On the top I have 4, and 2 plus the square root of 4, but then all that over 1, so this is going to be, let's see, 4 times, this is 2 plus 2, 4 times 4 is 16. Our answer is 16. Algebra, 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 right? That's what this is going to be about. Okay, I want to show you something. I'm going to do this problem a slightly different way. I'm going to do the exact same problem, but I'm going to do it a different way. This is good. This way I like. But I want to show you this because I want you to know it's possible. Okay, going back to the very beginning, taking this problem from the very beginning, we know it's bad, right? 0 over 0. What I'm going to do instead of doing conjugate, I'm going to pull that t out in the very beginning, okay? Okay, I pulled that t out on the very top, right? Now that didn't help, right? That didn't, nothing cancels, right? Nothing cancels. However, this right here, if you squint your eyes just enough, step back and kind of look at it, this is a difference of squares. But you have to like convince yourself. So let me show you that this is actually a difference of squares. What I can do is I can rewrite this by taking that number, taking its square root, which is 2, and then take the square root of this, which is root t, and then just put a plus here and a minus here. Now, if you don't believe me that this is actually these two multiplied together, then do it yourself. Check it. What's 2 times 2? 4. And then when we do 2 times negative root t, it's going to cancel with these two, which is positive 2 root t. So the middle terms go away. And then root t times negative root t is negative t. So what I'm trying to tell you is that you can always take the difference of two things and turn it into a difference of squares. If you see that, do you see that we get cancellation right now? Do you see that if this is those two, then we're there, right? At that point, we have, the only thing left is this and that on top, and a 1 on the bottom, which is exactly this line right here. So most of us are used to this, right? X squared minus 4, difference of squares, this is x plus 2, x minus 2, right? That's what we're used to, difference of squares. What you're really doing here is the x here that you're putting here is the square root of this. You're taking the square root of x squared and getting x. Then you're taking the square root of that number, and that's where you're getting the 2 from, right? I'm doing the exact same thing, but I'm doing the square root of that here and here, and then the square root of that here and here, and then putting a plus and a minus. All right, let's see if we have time. 5 minutes. Yeah, you know what, this is a good place to stop. So for your homework, did I not bring my book? For your homework on calculating limits, you're not going to do the whole assignment because we didn't cover the whole section. So let me look real quick, and then I'll get on Desmos. I'm going to need to bring up the ebook anyway. This homework assignment is very important. All right, it's a really, really important assignment. Wow. All right, so we want so for 1.4, I'm going to modify this assignment for now. I'm going to focus you down onto what's important. So forget what's on here for right now, okay? Forget what's on the calendar. For 1.4, I want you to try 11 through 23. And that's all of them, all right? So I would start with the odds. I would start with the odds, and then once you do the odds, come back and try and do the evens, because the odds you have the answers to, right? And then remember, I've got my solution videos as well. But do not just watch my solution videos. This is a great example of when not to just go watch my videos. Because the whole point is, can you sit there with that limit and start doing something to get it to work, right? If you just watch me, I know which way to go, right? So you need to learn that step. Questions on that? All right. Have a great weekend, everyone. I'm going to do that problem. So you were asking about 1.3. You wanted, and you said which one?
Number 15. It was 15 through 17, but I just didn't know how to put it into decimal.
How to actually type it in, yeah. Come on, stop. What are you doing? Okay, yeah.
When I just type the fraction, or would I have to put in the limit x?
Oh, no. Yeah, so look, what I would do here, I would type in, can you see this okay? I would type in, so to do square root, you just do SQRT. And then x plus 4 minus 2. So then I would do x plus 4 minus 2, all of that over x. So that's what I would do. I'd type it in like that. Do you see how I typed that? No limit or anything. And then what you were doing is we're trying to see what happens as x goes to 0, right? So on the graph, we're looking, here's 0. We're trying to figure out what value this looks like it's going to. See that? Now if we go right to it, it should be undefined. It's not doing it, of course. Yeah, but it looks like it's about 0.25. Yeah. Okay, thank you.
It's just, I thought you would have to put the limit.
No, the limit is the part you're visually trying to figure out where to look. It's saying, look, limit goes to 0, so you're looking at the x value of 0. Try it right here, right? If it said limit x approaches 1, you'd be looking over here. Got it? Yeah.
So the 26.
Yeah, hold on, let me turn this off. Yeah, let me get that.
You just got it? The guy sitting over there is also in the meeting. He's also